here we go. A couple explanations to help you better understand what's going on. So on question number 1, you had the equation in standard form, which means first you want to solve for y to write it in slope-intercept form, which is exactly what happened in my first step right here. Okay, so we wrote it in slope-intercept form, which is y equals mx plus b, where m is your slope and b is your y-intercept, since we're dealing with the linear function. And so happens b is at 2, so the y-axis is being intersected at 2, and we have a falling line because of a negative slope. There it is. Now, number 2, the slope is 5/3, and the y-intercept is at -2. So what you want to do is you want to start with the y-intercept at -2. That's the purple little dot. And then you want to do 5 up, 3 to the right, 5 up, 3 to the right. That's what the little triangles look like. Now, obviously, as soon as you have plotted a couple points, you can just connect and graph your line. Another way to do it is by the intercepts. You can calculate the x-intercept, at which point y is equal to 0. So on this side here on the right. And then you simply solve for the remaining variable. So happens the x-intercept is at 1.2. And on the other hand, you can obviously find the y-intercept on paper, which you do not have to do because you can just read it from here, -2. But if you wanted to calculate it and to prove that the y-intercept is at -2, you set x equal to 0 and you solve for y. And so happens it is -2. Then number 3, they're simply asking for the intercepts as well as the slope. Remember, the slope is easy to be found as long as you have perfect intersections with the grid. The best way to do it when intercepts are given is from one intercept to the next, up to the side. And it's 2/8. So when you simplify, that would be 1/4. Okay, the size of the triangle at that point doesn't matter. The simplest form will be the way to go. Okay, now number 4. That one is asking you to solve by substitution. And luckily, one of the equations is already solved for y. So all you want to do is replace the y in the first initial equation and then solve for x. Once that is done, you plug that value in to find y. The point of intersection, in this case, there's only one solution, which means one point of intersection. It's at 6,7. X value 6, y value 7. Okay, number 5. Number 5 is providing you with a system of linear equations, and they want to know where they intersect. So very easy, -2, 1. That would be the point of intersection. And then obviously, how do you know that it is correct? Well, the equations are not given. You would plug the point into the equation, into each of them, and see if your left side is equal to your right side. If it is, for both equations, then the same point is on each of the two lines. Therefore, it would be a solution. So similarly, over here, they're asking, okay, so basically it's like setting two equations equal to each other. So what is m? Solve for m. And you have to use the distributive property. Do recall when you have a negative in front of parentheses, it does distribute like a -1 into the first term as well as the second. So m is -38. You can prove that by plugging it back in for m, and you will see that the left side will result in the same number as the right side, and -38 is correct. So then we are on to absolute value. The little bars right there, that means absolute value. The answer is 8. It doesn't matter whether you have a positive or negative number in absolute value bars. For instance, if you had in -8, like this, okay, the absolute value of -8, the answer would still be 8. Why? The answer to that question is basically the answer to question number 8. Absolute value describes the distance away from 0. And because of that, distance really is always positive. So is absolute value. Okay, that's it.